Welcome to another presentation with information you'll find nowhere else. Our topic is anxiety and depression. I think by now most people realize that there is a very strong connection between your gut health and your brain. For example, over 50% of patients with IBS have comorbid depression, anxiety, or sleep problems. And the numbers are also very high for Crohn's disease and ulcerative colitis, just to name a couple more. What do these conditions have in common? Bad dysbiosis, an unhealthy balance of the players in your microbiome. And this gut-brain connection is not just for mood. It's also present in neurodegenerative conditions like Parkinson's disease and dementia. See those presentations. I'm going to try to explain this connection to you and the evidence behind it. We're diving into a very complex world, so I'll try to provide you with details, but at the same time, not overwhelm you with the biochemistry of the human body. So how do we get to this place of so many mental health issues? Excluding the genetic component, which in no way explains the prevalence of anxiety and depression, let's take a trip back in time. We evolved up until very recently in a very different environment. A world of 100% vaginal deliveries and 100% breastfeeding, providing our children with a healthy start in life. See my presentation entitled, Getting Started in Life with an Optimal Microbiome, to learn more about these topics. We ate whole foods and lived in a generally stress-free environment. Sure, there were moments of fight or flight, but they were rare in comparison to the rest of the time. We weren't exposed to antibiotics, proton pump inhibitors, junk food, and all the other things that negatively impact our collective microbiome. Nowhere on here do you see traffic jams, project deadlines, piles of bills to pay, alarm clocks, city noise and smog, and other constant mental stressors on an hourly basis. My point is as a rule, we aren't wired to cope with our crazy lives as they are. Combine that with the constant hits your microbiome receives on an almost daily basis, and the high rates of anxiety and depression are not surprising. Don't you just sometimes want to escape to a peaceful place like this and just get away from it all? But we can't, or at least we think we can't. And so when things get bad, people often run to the doctor's office. All too frequently, some practitioners hand out psych meds like they're candy. They even hand them out to children, even though SSRIs have a black box warning for increased risk of suicidality in children and young adults aged 18 to 24. And how well do these drugs even work? That's addressed in this study here. And when one drug doesn't work, doctors often prescribe multiple psych meds, performing experiments on their patients, hoping for the results. But what are the interactions and risks? And how about getting off of these drugs when you've decided you've had enough? How easy is that? I've seen what these drugs can do long-term to people, and it's not pretty. I'm not saying the answers are simple. Each person has their own experience, positive or negative. You have to decide for yourself. And if you're here watching this video, maybe that means you're looking for a different solution. Let's look at this growing issue we face from a different perspective. If your mental health issue has a strong genetic connection, perhaps a more natural approach can improve things. Maybe a little bit, maybe 25% or more. Maybe that's enough to help you be more functional. For most people with anxiety and depression, it's likely that you can make very substantial gains by addressing your microbiome, your inflammation, and your lifestyle. Life at times is not easy. Perhaps we should accept that before we go running to get that initial psych, which could lead us down a path we don't want. The need for temporary satisfaction at the expense of long-term good is something to consider. Some people love to complain, but don't seek to resolve their problems. I've been exposed to this too. Problem solving and action may help. For example, I helped a woman many years ago. She came into the office and we talked for an hour. She seemed perfectly healthy, just sad and depressed. Her words, not mine. So I said to her the following. We've talked for an hour and I have no magical pills in a bottle, dietary changes, or anything else I can offer you. From what I've heard, and I'm not telling you how to lead your life, this is solely an observation from an impartial person, that if I were in your shoes, I'd reconsider living in the moldy house you told me about and reconsider the toxic relationship you have with your boyfriend. I saw her about a month later, and she came in with lots of positive energy, smiling, and she told me she recently took up surfing. And I said, "What happened to you?" She told me that she broke up with her boyfriend and moved out of her moldy house. Sometimes it can be that simple, making a change, which is not easy. Most people fear change. But oftentimes it's not that simple. And here's where we begin our jump into biochemistry. The primary drugs used for depression and anxiety are called SSRIs, selective serotonin reuptake inhibitors. They modulate a key neurotransmitter which plays roles in mood and other things. It's called serotonin. Serotonin is also very abundant in the gut. In fact, the vast majority of your serotonin in your body is in your gut. Serotonin comes from the amino acid tryptophan, which is the least occurring amino acid in the diet, at about 1%. When you have inflammation in the gut, you can easily chew through tryptophan availability, which leaves little to cross into the brain. So there's the first connection between the gut and the brain. Dysbiosis in the gut, causing inflammation. Mast cells release serotonin, among many other compounds, as a part of the immune response in this ongoing inflammation reducing tryptophan to the brain. Part 2 is when there is dysbiosis, you have gut permeability. Then, problematic actors like LPS can escape, driving systemic inflammation, which changes the metabolism of tryptophan. Normally, 90 to 95% of tryptophan gets metabolized via the kynurenine pathway, and only about 2% into serotonin. But during inflammation, these key enzymes are upregulated and drive more tryptophan to the kynurenine pathway, which has a neurotoxic component to it and leaves less for serotonin. So the goal should probably be to address the root cause, something I talk about often. Let's see what that looks like. Chronic stress can be a root cause, but we'll cover that in its own presentation in the coming weeks. The other is a dysbiotic microbiome, which leads to too much LPS, driving systemic inflammation. Here we see the microbial fingerprint for anxiety and depression. This comes from my comprehensive meta-analysis of all relevant papers I could find. If you're familiar with my presentations, you'll understand this chart. But to summarize, at the bottom we see all the relevant taxa which comprise the microbial fingerprint. The y-axis is the count of studies where a significant difference was found between the control and the anxiety and depression cohorts. Orange indicates higher in anxiety and depression, while green is good, indicates higher in control. As you can see, the data is exceptionally consistent across all measures. In fact, it would be more consistent if it weren't for one crazy outlier paper from China. Otherwise, Coprococcus, Faecalibacterium, Megamonas, and Sotorella would be all green, and Eggerichella would be all orange, and Streptococcus would be more orange. So what's the point? Well, you have to read all the science. If you read just a couple of papers, you may walk away with the wrong impression, especially if it's a bad paper. Also, we need to account for outliers, here or anywhere. When you see such a clear set of data for, say, in this example, Faecalibacterium, the one negative finding out of 14 papers is clearly a statistical outlier, and oddly, usually these come from China. But we also don't see any Bifidobacterium or Lactobacillus playing a role as keystone taxa here. What we do see are many of the usual suspects I mentioned in my presentations, which I'm sure you're starting to appreciate. Let's take a look at a couple individually. Here we see all of my data points from over the many years for the genus Eggerichella. It's a classic opportunistic pathogen. As you can see from the color scheme, whenever a significant difference is found in a human fecal microbiome study for Eggerichella in healthy controls versus the cohort with a given disease/condition, almost always is this genus higher in the unhealthy. If we take out a couple of statistical outliers, like these two, it looks even uglier. There are 5 species in this genus, but when it comes to the data, we're really just talking about one species, Eggerichella lenta. As you can see, the 2 biggest spikes in negative data are for autoimmune disease and our topic here, anxiety and depression. E. lenta, along with other bad guys established in the previous slide, are certainly contributing to an inflammatory state in the brain. But why does E. lenta spike higher than, say, E. coli for psychiatric conditions? We know that E. coli LPS is more inflammatory and plays a bigger role in, say, dementia, another brain health disease. At this time, I don't have for you more precise biochemical explanation for the connection. But what I can tell you for sure is that the microbial fingerprint for mood looks like many others, with classic health-promoting taxa significantly decreased in those suffering from anxiety and depression, and classic opportunistic pathogens significantly increased. I've decided to highlight the genus Carbococcus this time, as I've highlighted others in the past like Faecalibacterium and Rosebury. As you can see here, the data from this amazing genus is very consistently excellent across the board. If we take out the outliers, it looks even more impressive. Once again, this classic good guy is an oxygen-sensitive butyrate producer via the acetyl-CoA pathway, which is carbohydrate fermentation. If we look at this now familiar slide to you, which is my collection of the great universal or almost universal health-promoting taxa of the gut, we see all these good actors are significantly reduced in many anxiety and depression studies, which we saw previously in the microbial fingerprint. However, there are many other good actors here, which are also reduced in multiple studies. Just the data is a little less robust. As you can see, there are large reductions on average in just about every health-promoting taxon you can think about. That means that the bad guys are in charge in the gut, causing inflammation, sucking up tryptophan, causing gut permeability, and sending large sums of highly inflammatory LPS into circulation, where the immune system will respond. And one of the many consequences of this inflammation, which is relevant for our presentation here, is the production of neurotoxic compounds combined with reduction in ability to make serotonin in the brain. And the sequence of events doesn't just result in anxiety or depression. These researchers here did a similar meta-analysis with practically identical findings. But there's a difference. Mine was solely on anxiety and depression and encompassed many more studies for those two, while theirs also included other psychiatric disorders, to include bipolar disorder, psychosis, and schizophrenia. The point being is that the same gut health promoters are reduced, and the same bad actors are increased across multiple conditions in the brain. So, although the driving force of dysbiosis and inflammation may include the same players, the diagnosis can vary, highlighting our individuality. As I say often, any given person may have a similar dysbiotic microbial makeup, but the diagnosis could be Crohn's disease in one person, dementia in another, and depression in someone else. But in reality, there's a lot of overlap. My data points for anxiety and depression come from 38 human fecal microbiome studies like this one. Here you can see how classic health promoters like F. Prozitzii and Carbococcus are consistently associated with higher quality of life indicators, as explained in the text box, and how Flavonifractor, which is a curious genus with lots of bad data points, which we saw in the microbial fingerprint earlier, is associated with lower quality of life. Or from this study, which had classic results, with Enterococcus and Flavonifractor higher in depression, and with health promoters like species from Eubacterium, Subdolly granulum, Fusicatinibacter, and F. Prozitzii significantly higher in healthy controls. And I thought I'd include some microbiome education perspective with some graphing I think is pretty cool. These researchers nicely graph the abundance of these taxa across all subjects to give you an idea of data across the board. Let's take Subdolly granulum, for example. It's a good guy. You can see here on the y-axis the relative abundance this genus occupies across the 90 subjects. Green represents healthy controls, and blue for subjects with depression. You can see how at no point this genus does not occupy more than 0.1% of the microbiome. Given that on average we have about 1,500 species in our colonic microbiome, it's actually more than it seems. The 90 subjects here are on the x-axis. As you can see how on average the healthy controls in green have a higher abundance across the board than the depressed. And in fact, at the far right, there are healthy controls with low abundances, but while a number of depressed have zero DNA from this genus. So let's do a general overview of what's going on in a little bit more detail. Here we see a nice model of gut permeability. On the left, we have the healthy gut. We established earlier that the healthy control subjects consistently have significantly more of these health promoters in green and others as compared to those with anxiety and depression. The environment maintains gut integrity, as shown here, which are the facets of what keeps the cells of our gut held together to prevent leakage into the body systemically. However, in dysbiosis, we have fewer of the good guys and more of the bad guys, highlighted in orange. This ugly environment leads to a breaking of the bonds which hold our cells together, allowing a host of things, like whole or parts of bacteria, proteins and peptides from food, and more to pass through the defenses. This triggers a robust immune response. For example, from the gut alone, incorporating about 70% or more of the body's immune system, 200 to 600 million neurons, and the largest endocrine organ in the body, the enteroendocrine cells, which comprise less than 1% of the cells which line the gut, but secrete a long list of molecules which have a wide range of effects. To highlight this crucial series of events, let's look at a couple of papers. We start with an alcohol dependency study. By the way, alcohol is not good for the anxiety, depression, and it's bad for the microbiome, and it's pro-inflammatory. Anyway, CT equals control, AD high IP is alcohol dependency with high intestinal permeability, and AD low is, you guessed it, alcohol dependency with low intestinal permeability. As you can see, 80 subjects with high permeability had a drastic decrease in the abundance of Rhamnococcus, Faecalibacterium, Subdoli granule, Bacillobacter, and Anerophyllum. 3 of these are a part of the microbial fingerprint. And I didn't even use this paper in my analysis. As a result of this dysbiosis in intestinal permeability, the alcohol-dependent subjects with high permeability were still characterized by higher levels of depression, anxiety, and craving, reinforcing the inflammatory connection between the gut and the brain. Here we have a paper which includes a number of characteristics seen repeatedly in the literature. Although they didn't analyze the microbiome, we can tell that there is dysbiosis. How? Well, first, we see that the levels of serum butyrate, which is a better marker than fecal butyrate, are significantly higher in the healthy controls versus those with depression. As I always say, I want to increase the butyrate producers. They determine the health of the microbiome. Second, we see significantly higher levels of toll-like receptor 4 expression. TLR4 is a component of the immune system, responsible for recognition and alarm in response to LPS, that common pro-inflammatory component of many, but not all, bad-acting bacteria. Because of this dysbiosis, we see increased gut permeability, literally with these tissue samples. And to the left of them, we see significant reductions in 3 of the proteins we saw earlier responsible for maintaining the gut barrier. Because of this, we see significant increases in inflammation. High sensitivity CRP is a systemic, nonspecific marker for inflammation. It is significantly increased in those with depression as compared to healthy controls. We also see NF-kappa beta, another key component of the immune inflammatory response, also increase in depression. And not increased in this study, but in many others, another key component is TNF-alpha, which is also often increased in mental disorders. Now let's review what the dysbiosis-driven systemic inflammation is doing in the brain. Here's a different look at tryptophan metabolism. Both pathways are important for health. On the left, we have the serotonin pathway. On the right is kynurenine. Perturbations of this pathway have been linked to a long list of conditions, to include anxiety and depression. Tryptophan metabolism is one of many, many victims of chronic inflammation. Inflammation driven by cortisol and an immune response in the brain to molecules like LPS from bad bacteria, which signal alarm, alarm, reduces enzymatic pathway, thereby reducing serotonin in the brain and increasing this pathway, resulting in more kynurenine. Additionally, this pathway is upregulated, which increases levels of neurotoxic compounds here. Overactivation of this neurotoxic arm of the kynurenine pathway has been observed in suicide attempters and in postpartum women with severe depression, while physical exercise increases this pathway. and the production of this neuroprotective compound. The link between mental health and tryptophan metabolism and tryptophan serum levels is well proven. This is why drugs which target serotonin are so popular. But why not just try something that addresses the root cause? We can also supplement with tryptophan as well, at least until things become stable. However, this comes with caveats. Not everyone should take tryptophan for a couple of reasons. But when it is indicated, it should be tryptophan and not 5-HTP. Why is that? Because 5-HTP already has passed the rate-limiting enzyme here. So it quickly becomes converted to serotonin in the gut. If you doubt me, take 1 to 2 grams of tryptophan on an empty stomach. You may feel nothing, you may get a little nauseous. On another day, do the same thing with 5-HTP. I would be surprised if you don't vomit. The serotonin from the 5-HTP conversion in the gut does not cross the blood-brain barrier, but tryptophan does. Plus, you can also give tryptophan in higher doses than 5-HTP. Other than tryptophan, how do we rectify this cycle to address mental health concerns? One way is via FMT, fecal microbiota transfer. See that presentation for much more information. In this paper, which you can get and read, they list 3 case studies. I'll just highlight one brief. After a slew of symptoms, a 66-year-old female patient elected to undergo FMT treatment. During a 4-year period, the patient had not returned for review due to long-term remission of her IBS symptoms. Interestingly, the doctor reported that the patient's global depression was markedly diminished after FMT. The patient had explained to the doctor that FMT fixed the pain that was ruining her life. Instead of looking at one person, let's look to see if FMT is applicable across the board. Here, 21 studies looking into the effect of fecal microbiota transplant on symptoms of psychiatric disorders were reviewed. You can see the design for some of them in Table 4. The authors concluded there appears to be strong evidence for the treatment and transmission of psychiatric illnesses through FMT. With FMT, we're switching out an unhealthy microbiome with one from a healthy donor. And the results are great, not just for mental health, but for many conditions. But FMT is a bit extreme. So let's take a look at how we can address your microbiome health more realistically. What I propose is the next best thing to FMT, driving significant change in your microbiome with properly blended and dosed prebiotics suited to the need of the anxiety, depression microbiome, which is the microbial fingerprint slide from earlier. Not only have I done the complete meta-analysis for all microbiome studies for these 2 conditions, but I've also done a complete meta-analysis for all the key prebiotics. I know which taxa they tend to feed, taxa which truly play roles in your health, not just a few species of probiotics. On that note, here in Table 1, we see the results from this review. They state that for anxiety, probiotics had a success rate of 36%, whereas diet/prebiotics had a success rate of 86%. And I don't even like their methodologies. I have a better system. These studies use single inferior prebiotics and at low doses. As for the dietary measure, it's a temporary fix. I explain all of this in my presentations. I have a better strategy. I follow the data dispassionately. I understand the science. I explain it all to you in every presentation I build. And the themes remain the same. The actual taxa may be a bit different from condition to condition, but they tend to share the same sequence of events, which are as follows. 1. We are born with one or more genetic weaknesses to varying degrees of susceptibility. We are also born via healthy vaginal delivery or via a C-section, which lacks a healthy initial inoculation in life. We are then breastfed or not. Here the stage is set. Number 2, we go through life with various diets, levels of stress, exposure to medicines which dramatically alter our microbiome for the worse, medicines like antibiotics and PPIs. Number 3, if the previous burdens are too much, the classic oxygen-sensitive, butyrate-producing, health-promoting bacteria are significantly reduced in our microbiome, while the opportunistic pathogens become opportunistic and cause inflammation within and without the GI tract. Number 4, this systemic inflammation results in what we call a diagnosis, which is dependent on genes, specific pathogens, and a degree of chance. Number 5, For some, those circumstances lead to a label of anxiety and depression, which may very well not be a standalone diagnosis, as many people with other diagnoses suffer from mental health issues. It's all tied together. So let's call it brain inflammation and serotonin depletion. This could be the result of chronic stress, which could also drive dysbiosis, or dysbiosis itself, resulting from the previous factors I highlighted. If you've been spinning your wheels for years, maybe it's time for something more intelligent. Let's get to the root cause of this cycle. Let's get your mental health back. If you found this presentation informative, I have many more for free in my YouTube channel and also in the Microbiome University tab on my website, themicrobiomexpert.com. There you can select from a wide variety of topics. And if you or a loved one are struggling with a disease/condition, I have condition-specific presentations as well, along with their microbiome protocols found within its respective tab on my website.